In this presentation, we'll be detailing our final design for the IMechE 2021 Design Challenge of creating a repeatable vehicle. We began our design by outlining our objectives and our aim, which is to design and manufacture the vehicle on time whilst following regulations and meeting our performance targets of accuracy, reliability, weight, cost and speed. It was clear that timing was crucial to the success of a project. Numerous tasks were dependent on the motor spec being outlined first, so that was an important consideration we made early on in the design.
When we began designing our vehicle, we had to calculate a rough estimate for the mass, and so we did so by using resources of the internet. Then we looked at the specific components and calculated a new revised mass. From the beginning, we found the drag forces, rolling resistance, and gear efficiency losses in order to help our calculations later on. Our success depended on the vehicle hitting the wall and coming back to the target which it started on. We found a minimum speed at which our vehicle was to travel at, and we designed our gears to meet this standard. And all our components for our vehicle fit within a £30 budget.
Here's an explanation of our mechanisms. On the left side, you see the linear gear mechanism, which I will talk about later. Here's the toilet paper mechanism in the middle. You can see it is attached to both axles. When the vehicle moves forward, it transfers the toilet paper from the front axles to the rear axle. When it moves backwards, it does the opposite. Thereby, when it reaches the end of the toilet paper, it turns it taut, and that turns off the mechanism. Finally, with the lead screw, you can see it converts rotational motion from the motor into linear motion in the lead screw. When the lead screw reaches the limit, it presses a button, thereby turning off the motor.
For our final concept, we chose the linear rack and pinion system. We chose this because it was the mechanism which had the fewest components, hence had the fewest points of failure. Fewer points of failure also means less mass than the lead screw mechanism, but not the toilet paper. It requires less torque, achieving our estimated top speed of 0.1 meters per second, whilst also being easily within the budget.
Here's an explanation of the linear gear mechanism. You can see the motor powers the linear gear and also the axle. Let's talk about the axle. When the motor turns, it turns the axle, making the vehicle go forward. Also, at the same time, it turns the linear gear, moving it away from the stopper button. When the vehicle is reversed, the wheels are reversed, the axle is reversed, and also the linear gear goes backwards in the opposite direction. Thereby, when it hits the limit, it presses the button, stopping the vehicle.
Well, to calculate gear ratios and to achieve an estimated top speed of 0.1 meters per second, 3 sets of compounded gears were required. 12 teeth on the faster gear was an additional estimate. Using the formula below, Z2 was calculated to be 79 teeth, and since no off-the-shelf 79 teeth gears could be found, an 80-tooth gear was used, increasing our initial estimate of the gear ratio from 282 to 296.
For our top speed calculation, we used the RPM for the wheel, and using the diameter of the wheel, we calculate the top speed at which our vehicle would achieve during this run. Then, for the maximum deceleration, we set up an ordinary differential equation and solving it. We are able to achieve graphs of velocity, acceleration, and precision. A plot is shown here, which is plotted in MATLAB, and the maximum deceleration our vehicle would experience is 3.93 meters per second squared, or around 0.4 g.